Okay, so let's continue on with our lecture of chapter 3. We're now going to talk about how do we name binary covalent compounds. So binary covalent compounds contain exactly two different elements covalently bonded. Typically, these binary covalent compounds are composed of two different non-metal elements. So for example, N2O5, SF4, etc. So we have two or more nonmetals covalently bonded together. Now, for binary compounds, we're a little more constrained. We have to have exactly two different elements, no more, no less. So for example, CH2O would not be binary. This is not a binary covalent compound because it has three different elements. So the way that we name these binary covalent compounds is you write the name of the first element in the formula. Now, you're going to then add a prefix if there are two or more atoms of that element. So, for example, if you have two nitrogen atoms in N2O5, you'd add the prefix di. So we'd have dinitrogen. Now, for your second element, you're going to write the name of the second element and you always add a prefix. So for the second element, you always add a prefix. So since we have five oxygen atoms, we use the prefix of penta. Okay. And then we write the name of our second element and we change the ending of our second element to IDE. So this would be pentaoxide. And in the case of oxides, if you have these repeat vowels, you just replace them with an O. So this would be dinitrogen. Oops. Pentoxide. So that would be N2O5. Now, suppose that you have SF4. Since our first element, we only have one atom of our first element, we do not include a prefix. So this would just be sulfur. Now, since we have a total of 4 fluorine atoms, we'd use the prefix of tetra. So this would be sulfur tetrafluoride. Now, for your second element, you always add a prefix. So for example, CO, for our first element, since we just have one, we don't have to worry about the prefix, so it would just be carbon. But for our second element, since we have one atom of oxygen, what prefix would we use? And don't be shy to type it in the chat or don't be shy to type in the chat. Yep, mono. So this would be carbon monoxide. Yep, exactly right. Perfect. So now that we've covered the rules, let's do a few guided examples. So PCl5, we're going to name our first element, which is phosphorus. We have 5 chlorines, so we use the prefix of penta, and then we change chlorine to chloride. For CBr4, we write the name of our first element, which is carbon. Then we write the prefix for our second element, which is tetra, and then bromine turns into bromide. In this last example, NO2, we write the name of our first element, which is nitrogen, the prefix of our second element, which is di, and then we change oxygen to oxide. So this is nitrogen dioxide. Do these examples make sense so far? Any questions on these examples so far? Okay, if there aren't any other questions, let's apply what we've covered to the following set of problems. So you're more than welcome to submit your responses via the chat, verbally, or via Canvas Quiz 3.17. So I'd like you to name the following compounds, and you're more than welcome to type the names in the chat, verbally, or via Canvas. And we'll discuss in about 3 to 4 minutes. Let's check to see how everyone's doing. So we already have a few responses that look quite good for the following examples in Canvas. Let's try to get a few more responses in Canvas or via the chat, and we'll discuss in about a minute and a half to 2 minutes. So you only put the prefix on the first element if there's more than one. For the second element, you always include a prefix. Did that answer your question? Yep. And we'll discuss in about another minute. Okay, let's look at the following examples. So S2Cl2, so we have 2 sulfur atoms, so you use the prefix of di. Then we write the name of our first element, which is sulfur. We then write the prefix for our second element, which is di for 2. Then chlorine turns into chloride. So this is disulfur dichloride. Let's look at the next example. N2O would be dinitrogen. And then since we have 1 oxygen atom, we use the prefix of mono. So this would be dinitrogen monoxide. For our final example, we have 2 phosphorus atoms. So we have diphosphorus. Then we have 5 oxygen atoms, so we use the prefix of pent. and then oxygen turns into oxide. So this is diphosphorus pentoxide. Do these examples make sense to everyone? Any questions on these examples? So looking at the Canvas quizzes, the responses looked quite promising. Any questions on these examples before we move on? If not, let's move on to the next example. Let's try to write the formulas of these compounds from their names. So let's write a formula for the following compound names. So dinitrogen tetroxide. So di tells us 2, nitrogen tells us we have a nitrogen, tetra tells us 4, oxide tells us we have an oxygen. So then we write this as N2O4. Carbon tetrahydride, carbon is carbon, no prefix, so that tells us we have 1 carbon. Tetra is 4, hydride is hydrogen, so we'd write this as CH4, also known as methane. Both names are valid. Any questions on these examples where we're writing the formula from the name? Any questions on these examples where we're writing the formula from the name? If there aren't any questions, let's apply what we've learned to the following example. So let's try to write the formulas for the following compound names, and you can submit your responses via the chat, verbally, or through Canvas Quiz 3.17.1. And we will discuss this example in about 2 minutes. So let's try to get a few responses. And if you have any questions, don't be shy to ask. I already see some students working ahead on these examples. Let's give it a few more minutes, and we'll spend about 2 minutes before we discuss this example in detail. And if there are any questions, checking Canvas, the class is doing quite well in these examples. And we have the full class responded and all of them are perfect. So let's discuss these examples. So nitrogen triiodide. So nitrogen, no prefix, so we just write in 1 nitrogen atom. Tri is 3, iodide is iodine, so we get Ni3. Perfect. Sulfur hexafluoride, sulfur, so we have 1 sulfur atom, hexa, 6, fluoride, F, so it's SF6. Perfect. The whole class did quite well on these examples. So let's continue on now, and let's look at the mixed nomenclature section. So this is really important. You're not going to get your compounds sorted by type on the exam. I'm just going to give you a formula and you'll have to write the name. So you'll need to classify the compound in order to identify what naming rules to use. So let's do some examples where we have a list of 3 different compounds and let's try to name them. So MgHPO4, so this is a typical polyatomic containing ionic compound. So we write the name of our cation, which is magnesium. Then we write the name of our anion and HPO4. So if PO4 3- is phosphate, HPO4 would be hydrogen phosphate. So this would be magnesium hydrogen phosphate. Looking at this next example, iron is a transition metal. So we have to use the rules for naming transition metals. Okay, so we need to figure out the charge. So if we have iron and the following polyatomic ion, we reverse cross the subscripts into the charges. That gives us Fe2 plus, ClO3 minus. So we name this as iron 2. And then what is the name for ClO3 minus? What's the name for that polyatomic ion? ClO3 minus?
Chlorate.
Yep, exactly right. So this is iron 2 chlorate. Perfect. Now let's look at another example, H2CrO4. So this is a neutral species, ergo we name it following acid conventions. It's a polyatomic ion, so this is a polyatomic acid. CrO4 2- is known as chromate. 8 turns into IC, so H2CrO4 turns into chromic acid. Does this make sense to everyone? Any questions?
Hi, I had a question about the iron one. So do we have to know if it's supposed to be ferric or ferrous, or can we just write iron?
No. You do not, you're not responsible for the old naming conventions for transition metals. This IUPAC method is more than okay. So you don't have to distinguish between ferric and ferrous. You don't have to worry about that.
Okay, thank you. And I have one more question.
Yep.
So then for distinguishing between the polyatomic, I guess ions and the acids, does the H always have to be in front? Like it's like the first element?
The main criteria is that the acid will contain only hydrogen and one other element, or only hydrogen and the polyatomic ion. And the acid is neutral. So if you see an overall neutral species containing only hydrogen and something else, be it a polyatomic ion or an atomic ion, then it will be an acid. Does that make sense?
Yeah, thank you so much.
Yep, perfect. So let's now discuss the next example. So I'd like you to take a moment and focus on naming the following 3 compounds, and you can submit your responses in the chat or via Canvas quiz 3.18. Practice really does make perfect for nomenclature, and this array of examples are exactly how these kinds of questions will be presented on a quiz or exam. You'll just get a compound and then you'll have to name it using the standard naming rules. And we'll discuss in about 3 minutes. Everyone's quite fast at these quizzes, but don't worry. Let's take the full time, and if there are any questions or if I see the whole class is done, then we'll discuss. And don't be shy to message me with any questions or your proposed responses in the chat or by unmuting and asking a question. And if there are any questions, don't be shy to ask them in the chat. Looking at Canvas, we have a pretty wide array of answers. Let's try to get a few more responses just so I can address common questions that the class has. Remember, focus on classifying compounds first and then naming them. And we'll discuss in about another minute. So let's take a look at how the class is doing so far in their responses. We have almost the majority of the class responding, and the majority of the responses are quite good. So let's now discuss these examples. So aluminum hydroxide is an ionic compound, and we have a polyatomic ion. So first things first, we write the name of our metal, which is just a main group metal. So we write aluminum. Then looking at OH we have to name our polyatomic ion, in which case this is known as hydroxide. So our full name is aluminum hydroxide. We do not have to worry about specifying the number of our polyatomic ion in an ionic compound, because ionic compounds, the number of polyatomic ions is implied by the charge. Does that make sense to everyone? Looking at MnO2, manganese is a transition metal. So we have to do some charge analysis. So we reverse cross our subscripts into our charges. We get manganese 2+ and O-. Now, that doesn't look right to me because oxygen should have a 2- charge. So we multiply both of our charges by 2. That gives us manganese 4+ and O2-, and all is right with the world. So we name this compound manganese, not magnesium, 4, and then oxygen turns into oxide. Let's do one more example. In this case, we have HClO2. So this is clearly an acid. It's a neutral compound containing only hydrogen and a polyatomic ion. ClO2 is chlorite. So ite turns into OUS when we're dealing with an acid. So this would be chlorous acid. Do these examples make sense so far? Any questions on these examples? Overall, the class did quite well on these. Let's do one last set of exercises, this time where we write the formula from the following names. So the reason why we don't put hydrogen, is that the hydrogen prefix only occurs when you have a hydrogen containing polyatomic ion. However, an ion is charged while an acid is neutral, has no net charge, so we name it using acid conventions. Did that address your question? The hydrogen prefix is used for polyatomic ions, which are charged. Acids are neutral, so we use the acid rules. Let's now take a look and let's try writing the formula from the name. This is probably one of the most important skills for processing word problems in chemistry. So we have iron 3 nitrate. This is clearly an ionic compound. So iron, we're told, has a +3 charge. Nitrate is NO3 minus. We cross our charges and that gives us FeNO3, 3. So acetic acid, we're dealing with an acid. Acetic is derived from acetate, which is CH3CO2 minus. An acid has hydrogen and a polyatomic ion. We cross our charges and that gives us CH3CO2H for acetic acid. Do these examples make sense so far? Any questions so far? Let's do one more example. Ammonium is a polyatomic ion, which is of the form NH4+. Oxide is an atomic ion derived from oxygen. We then cross our charges and that gives us NH4,2O. Do these examples make sense so far? Any questions? If not, let's apply what we've seen to the following problems. In this case, you're asked to write the formula for the following names. And you can submit your responses in the chat, verbally, or through Canvas Quiz 3.18. And we'll discuss this example in about 3 minutes. Let's try to get a range of reasonable responses, just so that way I can get a sense of how the class is working their way through the material and any questions students may have about the material. And some students are quite fast at this. We already have a few responses, but let's take the full time. And if you have any questions, don't be shy to unmute and ask them verbally, to ask them in the chat, etc. Let's try to get a few more responses in the chat or via Canvas, and we'll discuss in about 1.5 minutes. And if there are any questions, don't be shy to ask them in the chat or verbally. So looking at the class's responses via Canvas, Almost everyone has responded so far. So let's now discuss these examples. So first and foremost, cesium hydrogen sulfite. So this is an ionic compound. We write the name of our cation, which is cesium. Hydrogen sulfite. So sulfite is SO3 2 minus. Hydrogen sulfide is HSO3 minus. So we write the charge of each of our cations and anions, and then we cross the charges to give us cesium hydrogen sulfate. Hydrochloric acid, the hydro prefix tells us we're dealing with a binary acid and that the binary acid is aqueous. The hydro prefix, we look at hydrogen, which is H+. Chloric is derived from chloride, which is Cl-. We then cross our charges and that gives us HCl aqueous. Perfect. In our final example, xenon tetrabromide, this tetra prefix tells us we are dealing with a binary covalent compound. So we write out our first element, which is xenon. Tetra tells us we have 4 of our second element, and bromide is based on bromine. So xenon tetrabromide is XeBr4. Any questions on these examples? Any questions on these examples?
Was that 3.18?
Yes.
Okay.
There are 2 of them.
Okay, yeah, because I was like, I thought we just did that one.
Yep. Any other questions on this example? So there is another section that I want you to keep as your reference that we'll come back to on organic nomenclature. If you're planning on taking organic chemistry, this would be a good point to refresh over. We'll talk about this more when it comes up in a few later chapters. So that's it for chapter 3. So let's end the recording.